Hey everybody, welcome back in. Mr. Marone here. So today we're going to kind of put all the pieces together. We've been talking a lot about parallel lines, and we're going to now take a look at them on a coordinate plane. So here we've got this example of a gondola that we're going to take a look at. So the gondola is 20 feet above the ground, all right, and it's on a hill, so it's going up, and it says that both of them have a slope of 1/2. So the slope of the hill is 1/2, and the slope of the cable that's holding the gondola goes up by 1/2. And they want to know what's the geometric relationship between the hill and the gondola line. So if we think about this, we don't want the gondola to ever hit the ground, correct? I think that's probably a safe bet that while the gondola will lower itself towards the ground for us to get off, if you've ever been skiing, that's a good thing. But we don't ever want the gondola to just go into the ground. So what we notice here is that these are parallel. They're never going to intersect at this current rate of having the slopes be the same. So that comes up with a huge rule for us when it comes to parallel lines, and that is that their slopes are always going to be the same when they're graphed on a coordinate plane. So this theorem tells us that we have two non-vertical lines, any lines like our gondola and our hill, they're parallel if their slopes are equal. So P and Q are parallel here if the slope of line P is equal to the slope of line Q. And if they're vertical lines, they're going to be parallel as well. We kind of know that on the vertical or the horizontal situation, but we now can do it for any of them, vertical or non-vertical. So we're going to take a look at a couple of these. And try to determine are they or are they not parallel. So all you're looking for is the slope here. So they've given us lines K and N, and they want to know, are they parallel? Well, I'm going to look for points that are on the cross marks of my graph. So for point K, I'm going to change to a different color than red. For point K, it appears I have this point here, -2, 2. And it also looks like I have this point down here, which is 2, -2. So if I find the slope of K, I'm going to have 2 minus -2 over -2 minus 2. So that gives me a slope of 4 over -4, or a slope of -1. If I do the same process for N, it appears that I've got the point 1, 2, and that I've got the point right here, 4, -2. So if we do our slope here, I've got 2 minus -2 over 1 minus 4. That's going to give me 4 over -3. That's not the same as -1, so K and N are not parallel. Go ahead and try example 2. They want to know, are lines M and Q parallel? When you come back in, we'll be able to verify whether or not they're parallel. Go ahead and try it. All right, welcome back in. So as we can see here, when I worked through line M, I had 2, 5 and -4, 3, and it gave me a slope of 1/3. And when I did this for line Q, I had the slope of 2/5. So those are not going to be parallel either. They have to be exactly the same. One thing to point out is that if you do have 2 over 6, you have to simplify anything down to its smallest fraction to make sure. That's it when it comes to parallel lines. If you have any questions, bring them into class tomorrow as we go into the whiteboard problems, and have a wonderful evening.